that discovery. Later, I will explain the methodology, the one we can find in the literature, and the second one, that is the one we propose. After that, I explain the material that we use, I mean the software and data. And finally, we'll show the result, the conclusion, and future work. So, well, probably, oops. Yeah. Well, I think
there's a problem with that key in particular.
I think so. Wait.
If you want to use the mouse, I don't
know. What's the matter?
Swedish? No.
¿Qué pasó? Okay, okay, so well, probably you already know, but I mean, because this 2 years of pandemic, but this is, I wanted to start just explaining the process of that discovery. So from the point that we identify a disease until we get the medicament, approve it, it's in circulation in society. So it's been a lot of years. Actually, maybe if I have time to say that, for COVID, we still don't have, or I don't consider we have still a vaccine, because we are only reducing the problem that it generates, but actually it's not avoided completely. But well, this is the whole process. And in my research, we focus on is focused in this 3 parts, which is related with identification, validation, the pharmaceutical target, and also the lead molecules. But all of that relate with the computer side. Actually, this is the most expensive, or yes, the longer part in this process. So, well, we need a lot of time in this part, because from one side we need to identify, or we need to explore the biological space, and the other side we need to consider also the chemical space. One of them is for the human protein, to identify the human protein which is attacked by the disease, by the virus. And when we have identified that one, we need to explore all the compounds that we can find in nature, just to try to find which is the most interesting. So this is the work of that discovery does. But, well, I just want to remark that even if we identify the pharmaceutical target, we still need to compare with 10 to 20 different classes of compounds. So this process can be done in 2 different ways. One is lab screening, which is automatically system, but it's very expensive because we need to buy the elements. So the second, or the other way, is use virtual screening, which is carried out with computer. So we can reduce the time and cost in this process. And also, this virtual screening is a pre-stage of the lab screen. So we filter the compounds, and then they go to the lab screen. And in this presentation, I'm going to focus on similarity methods, which are, the idea of test method is search molecules which have similar descriptors. Inside of this method, there are 2 ways to do it. One of them, which is the most common, is rigid molecules, which the idea is just, the similarity method, you have one molecule and you have a database. So in the end, you need to find, you need to overlap the 2 molecules just to find which is the more similar. So in literature, the most common is to find rigid molecules, but the reality is just you have one molecule in this position, let's say, and the other one is like here. So you need to find, in the end, the approximation, the rotation of the angular atoms, just to find the best position. So in this work, the idea is just to go a step forward and work in flexible molecules. And also, to do that, there are 2 different ways. And just this is the topic, or the proposal of this work. In one of them is just working with generate conformation, where conformation is the same molecule but with different position. So one of them is working as using just the molecules, generating conformation, and using a rigid. And the second one is generating this conformation inside of the optimization time. But this one is more difficult. It's a more difficult problem to solve. So maybe for next year, we will. I will propose a solution of that. So I'm going to focus in your left side. the working as read. So what do I propose in this work? First of all, analyze the database to obtain information about the feature of these molecules. After that, calculate distance to obtain the more similar compounds, just to filter them and generate confirmation only for giving a big data set and generate confirmation only for a small set of these data sets. So methodologies. Well, this is what is done in literature. And when we use rigid molecule, I mean, we have a molecule, reference molecules, and we have the database. So in the end, we need to optimize any scoring function and to find the more similar one. So we compare with all of them, we obtain the scoring value, higher is better, and in the end, we sort it. This is the traditional one. So now what we propose, okay, I push the button. So what we propose? Well, first of all, we have the database with the different molecules, and we obtain 5,000 descriptors for each one of the atoms. After that, we apply the descriptor engineering, just to apply correlation. I mean, if correlation is high, I mean, if different columns have a correlation higher than 0.8, we remove all of the columns, just keeping one of them, or removing the column with empty descriptor. So in the end, the idea is just reduce this number of descriptor in a small data set, in a small subset, sorry. Once we get that descriptor, we calculate the Euclidean distance from the target to all the different queries. And we obtain the more similar one, which are the ones that we filter. And for this subset, we generate in the end the conformation. So here is where we are applying the flexibility of the compounds. Okay. When already we have all the conformation of the query and the target, so just is apply the original method, the literature one, comparing, optimizing for each target or for each conformation of the target, all the conformation for all the queries. So in the end, we get this, for example, in this toy sample, we get that the most similar one is for the target, the conformation number 3 of the target, or this is 1, this is 2, this is 3. I mean, for this conformation and the conformation of the query 1, number 2, we obtain that value. So this is the method. Now, well, to do that, well, the scoring function that we use is electrostatic similarity. I will explain it briefly. This is just a summatory of potential, electrostatic potential for each one of the atoms. Well, this is also a small mask. That, I mean, we have a masking function just to be, because we have this atom, so we don't want to consider the electrostatic potential inside of the molecule. So we remove it with this expression. And in the end, we have H with this, because we have the molecule, so we create a grid which contains that molecule. So H is just the size of the step. So the lower value of H is more accuracy the problem, but it's more expensive too. But well, all of that is given. So in the end, the important thing is just we normalize that scoring function, and we obtain a value between minus 0.33 to 1. One means two molecules have the same electrostatic similarity. It's going to decreasing until 0 when the two molecules are completely different, and it increases again in a negative way just until 0.33, which means the two molecules have the same scoring function, the same potential, electrostatic potential, but we changing the charges. I mean, positive, negative, and negative, positive. And the software that we used was Optifan, which is an evolutionary algorithm. It's already published in 2019. The idea was a global optimizer, which explore the entire cell space, but also have a local optimizer for the problem. As I said, the idea of Optifan is maximize the similarity given a query and a target. But I don't want to focus on that just because it's already done. But For this conference, so this work, we included two improvements. One of them was reduce the number of the dimensions of the problem, because first we consider, to make a rotation of the molecule, because one of the query is just fixed, but the target molecule, we need to move it around this, the space, just to get the overlap. So in the previous work, we use system parameters, because we use two 3D points and an axis to generate the rotation with quaternion. But in this work, we improve that method, changing the quaternion with semi-sphere parametrization. So we only need two angles to generate the axis, and one of them, first one, to rotate according to that axis. And the second improvement we did is just incorporation. We have some knowledge, problem knowledge. So in the previous version, when we are rotating, for example, 3p, it is stuck in 2p. But now we are allowed, for example, in this case, in this figure, we have 2p plus 90 degrees. So we consider just to keep 90 degrees. In the previous version, it will be keep in 2p on 0. Well, another result, the data, this software, this problem was applied drug bank database. It's around 10,000 compounds, but we focus on this subset, which is validated by the Food and Drug Administration for US. And for the experiment, we selected randomly 20 molecules, and this is just the parameter of Stefan. So what we obtain is the following. Here we have the rigid methodology, where the more similar compound to this target is this molecule with a value of 0.37. But if we do it in the flexible way, just explaining all this step, the most similar compound is 9,237, the conformation 43. Obtaining a scoring value of 0.76 is much higher. And if we find this molecule in the rigid ranking, the position of this molecule is in 1,500 almost, with this value. Graphically, which is easier to see, we have this is the molecule. Okay, maybe you can think, I explain first. Red is the negative charge, and blue is positive charge. And cyan is related with blue, and pink is red. I change the color to visualize it better. So we can see here the result. In this case, we can see there are no too much overlapping between the charges. So that's why the score is this one. But in the flexible way that we are generating different positions of the structure, in the end you get a better electrostatic similarity. Because probably most of this value is because of these two charges. And to show this is another study case. I picked just two molecules. This is so for the rigid methodology. This is the most similar compound with this value 0.5, and applying flexibility, we get a much higher value, and it's the same behavior that I explained in the previous case. And if we represent it, we can see here the difference. There are not too many, not too much overlap. But in this case, we can see all this part is almost the same. So now just to finish the conclusion, we did two improvements. In one hand, on Stefan, we're reducing the number of optimization parameters, reshaping the range of freedom in some of them. And in the case of analyzed data, we analyze, we have a database, so we analyze the descriptor and apply filter, as explained before. And the results show, obviously, higher scoring value and less evaluation function, but the part of the less evaluation function because we improve Optifan. But the most important thing is just we save 264 computing days. This is why, because we have the database 1,700. So if we generate conformation for all of these molecules, and we can apply virtual screen, just optimize the function. Well, it requires a lot of time. So in that way, with the methodology that we propose, we filter, so we just selected the 10% of the the 10% of that database. So we saving that. That's the reason we save that time. And just a future word, the idea is, as I said initially, implement a confirmation generation algorithm as an internal method in Optifarm and including a scoring function. Well, this is my collaborator from the University of Almeria, my supervisor now in Sheffield, my collaborator also with in Laucan, in the chemistry part. That's all. Thank you so much.
Thank you. Any questions?
This is the last presentation I understood that Optifarm is the software that you are using and that you are working on that, so you implemented the optimization algorithm evolutionary. Can you explain the
Yes, I mean, well, Optifarm works.
just to say or
It's more or less easier, but I didn't actually have I took around 20 minutes, so that's why I didn't include it. But the farm works, I mean, initially generate 5 initial solution, because we included some information, problem information. For example, the initial solution is just one of these, the 2 molecules that we want to compare, aligning and center in the center in 0, 0, 0. And the other 4 solution is just rotating 180 degrees in each one of the axes, because we did a previous analysis and we found this is the right solution. And after that, after the solution, the farm going, I mean, each species defined by the solution and also by a radius. So in each one of the steps, the radius is reducing. So that's why I explained the farm parameter. So that's the software.
so yeah, I understand. So the idea was to have not many iterations to solve the problem.
Yes.
Iterations and time.
Any further questions? Well, thank you again. And the second presenter is Flip Alt, and he's going to present solving a complicated waste collection problem using an open source tool. Go ahead.
Hello to everyone. My name is Filipe Alves. I'm a PhD student from University of Minho, and with partnership with my colleague Adriana from Institute Polytechnic of Bragança, we and our supervisors, we developed this approach, our work that are entitled a solving capacity waste collection problem using an open source tool. So the main idea for these presentations, I will start with a brief introduction, the main strategies, the methodology, some results, some conclusions, and some ideas for future work. So As you know, some statistics, for example, by European Union, says that by 2050, most populations will be concentrated in cities. Forget the small towns, small village, and so on. And for that reason, normally the probability to generate a great amount of waste is higher. So we have a big problem and we will generate complexity in basic services. In Portugal, that are the case of my study, we have around 33% of the households producing the waste. And you can see that are a great amount when compared to other situations. In this graph, for example, you can see the amount of waste produced by Portugal and the total the waste total produced by the European Union. As you can see, we have a big percentage when compared to the other countries. So, as you know, the waste management system starts with people. People produce waste. After that, we have some private or municipality company that produce the waste collection. After that, they collect the dumpster with the waste, return to the depot, to the plant, and there they will recycling or proper disposal and so on. But the idea here is today in Portugal, of course, normally the trucks or the guy that take the truck decide which dumpster needs to collect. Our idea is to take that information, take the location of each dumpster and try to optimize all the routes that we have at disposal. Our idea is to use an open source tool, take the real data and produce specific routes to optimize our strategy. So the idea, as I said before, is to produce our study in Bragança, in the district of Bragança. Here we have the map of Portugal. In Bragança, here we have a very nice image from Bragança, of the castle. Resíduos do Nordeste is the company, is the municipality company at the city. Here we have, I put some information about the city from Bragança. We have 13 municipalities, around 134,000 citizens. Also, we have some percentage about the selective collection. Also, the selective collection are increased in the city. That are a good thing. And I think that are okay. So our main goal for this work is optimize the collection routes using an open source tool that are Untitled Google OR tools. You can search on the Google that are developed by the Google Enterprise. Our idea is define which is the best algorithm because they have a lot of algorithms. We select just 3 heuristics and produce a small comparison with the real scenario that are executed today. The methodology for our work is generate an initial scenario. As you can see, we generate some locations of the dumpsters that are the real ones. And we also produce a NERVI analysis that I will explain later. This data will produce our input to put in the system. These systems will feed our code that are implemented in Python. And our idea with the platform is to produce 3 examples of optimized routes. Started with the central depot, go to the dumpsters and return. Our idea is to define which are the best one. Related to the Google OR tools that are the symbol of the software is an open source, fast, portable software, open source that are really nice and are very nice to solving complex combinatory problems. I think the software are developed just in 2019, very recently. They present programming environment, easy to use in different languages like C#, Python, Java, and so on. Related to other criteria of the software, we have flexibility in the algorithm modification. That is really nice. Also deals with vehicle routing, integer, linear programming, constraint programming. Also, we have quality of the produced solutions. Also, a very nice thing is we can integrate the software with some software, some skills, some microservice on the internet, like Google Maps, Google Distance Matrix, and so on. And also, they have some testing tools that are good to test. So, return to the methodology. Our idea is to initialize and update the daily labels of each dumpster, pass the information to as input for our system. The idea is one collection every 2 days. These first two models are connecting with each other because, for example, when the dumpster are collected, we can set as 0 and we know that the dumpster are collected. After the second model, we have to optimize the routes using the software, and we get the objective function that are the daily distance and the loads. So here we use the Google Earth software to apply where is the location of each dumpster. For our case, we use 20 dumpsters. To generate our NERVI analysis, for example, here I select the location 1 in the city of Bragança, and I can see all the houses that are NERVI of the dumpster. Here, to generate our NERVI analysis, I will try to explain our idea. We generate first a filling velocity that are shared in the screen. This is equal to the filled area of the part that are in red, divided by the total area, multiplying by a stochastic parameter, an oscillation parameter that can generate a stochastic behavior to manipulate or try to understand if the dumpster are more with more haste or not. We generate these equations for all the dumpsters. This filling velocity, this filling function are using to prevent or try to know the daily level L of each dumpster for each day, and also the daily volume of each dumpster. Also, for example, in the daily volume of each dumpster, we can assess, for example, the total volume, the dumpsters, and we use these two equations to generate the NERVI analysis. Related to the methodology, here we apply the decision variables that guarantees that each truck visits specific locations after the location before and 0 otherwise, and we try to guarantee that each truck normally visits a specific location that are the generic capacitated vehicle routing problem. Related to the mathematical formulations, the objective function is try to minimize the total distance. That are subject to, for example, we try to guarantee that when a truck visits a specific purpose needs to go out. We try to guarantee that we need to start at the depot and end in the depot. Also, we try to guarantee that the full capacity are not ultra-paced. So the idea is to use some capacity constraints. And for example, in 6 and 7, we have the subtour elimination. As the results, our system, as I said before, is comprised of 20 dusters that are studying for 30 days. We just use 3 trucks for this study, and the capacity are 16 cubic meters. The dumpsters have this maximum capacity, and the distance matrix are using with a microservice from Google Maps API that are connected to the software. As the results, in the left side, we have the distance traveler, that are the objective function, and in the right side, we have the execution time. As you can see, we use 3 specific algorithms that are in the platform: the guided local search, the taboo search, and the simulated annealing. The 3, we have the results of the objective function for each the algorithm and also the execution time. As you can see, the best one in that case was the guided local search. That is a small difference. I also generate a small remember. All three algorithms are optimizing routes, so it's normal. Don't have no significant difference or significant difference observed. There is a not bad result. Also, we code a small function to generate to take the solution and apply in a graphical manner just to show the examples of each location. As you can see, some of the solution generate different routes. That is normal. Also, as I said before, we have three trucks, but the solutions just use two because the capacity are exceeded. And there is no visual difference in the routes that are found by each algorithm, as you can see. So our system is comprised of 20 dumpsters and 3 trucks, but the real one has around 192 dumpsters and 20 trucks. This is so just to understand the real part. So we have the real data of the trucks, consumption, and the loads that are carried annually. But how we could compare with our idea, our results with the real one? So we have an idea that are producing or generate a collection cost, that are our collection cost functions, that are using the total load carried divided by the total cost that are using on the company. For this part, we just use real data that are treating using just the timestamp in this study. So the idea is to analyze that functions and try to produce, of course, they don't use any computational support. So, of course, when compared with the collection cost, it's normally to have optimized results. In this case, we just use the paper waste part, not the plastic or the glass, just the waste part. So a comparison with the real scenario cost shows the powerful the optimization support of Google OF tools can be. As the main conclusions, the Google OF tools was able to solve this capacited waste collection problem in the city of Bragança. The guided local search was the best algorithm when compared with the other ones. The tool was able to also to produce a graphical visualization, representation, and also you can generate the effective cost saving when compared with the real scenario. And thank you for your attention.
Thank you, Philippe. Any questions? I have a couple of questions. You were presenting an online tool, open source. First question is how easy it is to use and how good it is, your feeling. And the second one, what is for that software guided local search? The other ones I know, guided local search, I don't know exactly what it is.
I don't know too. I'm saying the truth. But related to the first question, for me, it's a very nice software. I will use in my PhD thesis. My idea when I plan, I don't know nothing about Google OF tools, but now I will use in my thesis. I will produce some specific part in my thesis. But I think that solution is very fast to get solutions. It's very fast to modify the algorithms and apply in my work. It's very fast. For example, I use for Python, I can codify and translate to Java. It's very easy to apply the software. So I think that a really nice software, open source. So for me, are amazing. The second one, I already said. I already used the Taboo search, yeah, and I know the simulated annealing, but the guided local search, yeah, I have problems.
That was the question also of Elysius, and I think we should look at Google and try to figure out what is
the local search.
What is the local search? Because they are different.
Yes.
Okay. Any other questions? Thank you. We move to the third talk. And it will be an online talk. It will be presented by Francisco Santos. Can you hear?
Yes.
Okay. And the talk is a systematic literature review about multi-objective optimization for distributed manufacturing scheduling in the industry 4.0. Go ahead.
Sorry. Think about the yes.
I'm sure Francisco will be back.
Yeah, he might be reconnecting. We are having some technical troubles. Please keep connected.
You was on for some reason. I'm sure you will be back. I am not sure, but I hope you will be back.
Are you in contact with him? Or okay.
Yes.
Okay. I'm sorry.
It's okay, Francisco.
Okay.
Can you share your presentation?
Yes. Yes, I share my.
Go ahead.
Okay. Can you see my?
Yes. Can you put full screen?
Okay.
Right.
Thank you. Good afternoon. I'm Francisco Santos. I'm a PhD student in industrial and system engineering at the University of Minho in Portugal. The topic that I am going to address is a systematic literature review about multi-objective optimization for distributed manufacturing schedule in the industry 4.0. The outline of my presentation is first a short introduction, then I will present the methodology, the results, and the discussion. I will also address some conclusion and finally the reference. To identify the advancement that has been made in multi-objective optimization appear to distributed manufacturing scheduling in the era of industry 4.0, a systematic literature review was conducted. In this work, the following research questions were formulated. 1. Is multi-objective optimization being applied to solve the distributed manufacturing scheduling problem in the current Industry 4.0 era? 2. What are the main issues that arise when, when studying MOO DMS in the Industry 4.0? What else can be further explored for solving this problem? In this work, three platforms were used to collect data beyond Web of Science and Sculpture. To answer the research question, a systematic literature review was adapted. This methodology is illustrated in Figure 1 and involved the following three main steps: input, processing, and output. In the input phase, the objective, the search are defined and the search term are identified. The processing phase is where the whole process is done in order to obtain a desired result and includes five steps that begin from planning and formulating the research question to the interpretation and result presentation. The keywords considered is in this work were multi-objective optimization, distributed scheduling, industry 4.0, and manufacturing and manufacturing. For the three platforms, Scope, Web Science, and Beyond, 615 articles were identified. The articles that did not meet the inclusion criteria were excluded. Some articles that were not peer reviewed and repeat were also eliminated. After all this process, only 33 articles were selected in this study. Now, I will present some results regarding the 33 selected articles. The first figure in the left side shows the evolution of publications per year. In this figure, it is represented the publication in the time interval between January 2010 and March 2022. The ICER number of publications have been reached in 2020. The second figure shows the editors of the publication. Most publications are from Taylor and Francis, Elsevier, and Springer. From the result obtained, 33 articles were considering that met the condition set to answer the research question. The characteristics of these selected articles were analyzed. This table resume the reference in terms of the criteria. From the user criteria from the user criteria, only two articles present three keywords. Even then, keywords multi-objective optimization appear in most of the articles. Next, we present some issues included also the work related to multi-objective algorithm in industry and energy consumption in industry and planning in production lines. Now, I will provide some details about the most relevant articles found in different areas. Firstly, in the multi-objective algorithm in industry. In this paper, a new efficient two-stage NSGA2 algorithm was proposed and the result compared with the original NSGA2 algorithm in portfolio optimization. A flow shop scheduling problem under consideration of multiple objective and independent processing time and uncertainty is investigated. Several multi-objective meta-heuristic optimization algorithms are used to generate optimal solution for microchip and micro machine applications. Comprehensive multi-objective optimization model for task scheduling, enabling cost reduction from both the customers and the suppliers point of views it's presented. Um, Scheduling is an area that has attracted attention from researchers due to the massive energy consumption of the manufacturing process. Some example of papers in this area a multi-objective optimization for wind and thermal power system is proposed. This paper presents a multi-objective stochastic optimization algorithm to analyze the energy consumption, contraction period, and demonstrated it is benefits in the contraction process considering random events. A multi-objective optimization algorithm to improve productivity and reduce cost and energy consumption of autonomous industrial process. This work addressed the simultaneous optimization of the of the make Spain energy consumption and cost while allocation results for robot workflow task. Solution approach for multi-objective optimization in vehicle-based automated storage system. As for planning on production lines, We will mention some study articles. A distributed hybrid flow scheduling problem will multiprocessor task considering object two objectives simultaneously is addressed. This course proposed an optimization method based on data analysis for distributed process planning. An integrated scheduling process in a distributed manufacturing system is investigated. An approach to cloud-based distributed optimization for factory scheduling and process planning is presented. Um, we concluded that there are some recent applications of multi-objective approach to solve distributed manufacturing scheduling problems. However, this is an area that is starting to grow, and since the large amount of data available in this industry 4.0 era, it is expected to see in near future new relevant development. One of the future trends of the job shop problem scheduling in the industry 4.0 should be in the development and use of different kind of approaches, namely based on artificial intelligence, such as intelligence agents. The use of multi-objective optimization approach and methods to solve distributed manufacturing scheduling problem in the context of the industry 4.0 should be further explored. This kind of scheduling problem should continue to be oriented to the current requirement imposed by the industry 4.0. They remain underexplored. And these are the reference. And thank you very much.
Any question? Thank you, Francisco. So we move on to the last talk that will be presented by one of our hosts, Pablo, and it's also co-presented because Eligios is online by me. And the talk is on active set LP algorithms allowing basis efficiency. Go ahead.
Ese.
Sí, presentado.
Okay, thank you, Humberto. Let me tell you a couple of things about the linear programming algorithm. It's a joint work with Eligius, and it's a active set algorithm. And the main point here is I'm trying to work with a basic matrix which is not a square, and how we can manage it to be able to develop some interesting things in linear programming. Let's start with the first part of the talk with the notation, the primal non-simplest set algorithm, and the relationship with existing methods. In the notation, you can show that this is my primal problem, and you can see that we are not using standard notation because we want to emphasize geometrical meaning of the entities involved. We don't want to talk about reduced cost. Reduced cost is not geometrically meaning nothing. We want instead to be able to listen to talk about the residuals of the primal constraints, so much geometrical meaning. And it's the linear constraints, and the y variable is the multipliers of any linear constraint. Really? And in the I variables can be divided, or as always, in basic and non-basic. But the point is that a basic set is not a square. If we denote with AK the columns of the A matrix with the BK basic variables, the point is that MK, the cardinal of this set, is less than or equal N. No? And of course, the non-basic is the complement of the or the number of all constraints in this set, and NK is defined accordingly, right? The I column of A or the A transpose row or A transpose is the corresponding row on A transpose, and the range, the subspace formed with a linear combination of the columns of a matrix A is denoted by LA. Okay, right? This is the primal feasible region, and this is the dual feasible region, right? Okay. It's a precedent 50 years ago with a dual non-simplest active set algorithm. It's from Gillan Murray in 73, and he only developed the dual, the analogous to the dual simplest method, but they didn't do the primal counterpart. And then we are going to state what's the what it looks like in this area. Okay, it's in our notation. It's a primal feasibility search. Look, we are starting with a feasible dual point, and we want to achieve primal feasibility. In this loop, we are going to maintain dual feasibility, right? And we start with by solving this underdetermined. This is not a square matrix. We are solving this underdetermined linear system, and then we compute the residuals corresponding to this primal point. Of course, the residuals corresponding to the basic variables, to the active set from the primal point of view, are 0, and the residuals for the non-basics are defined like this. Have you obtained primal feasibility? Then you can stop. You have the optimal solution. And in case not, you can select a non-basic, like in the simplex, the primal simplex. In the usual simplex algorithm, you select the constraint or the basic variable or the non-basic variable to be added to the basic set of variables, right? And the difference with the user primary simplex is that AP can be in the range space of the current basis, deficient basis or not. In the usual simplex, AP is always on the range space of AP. And in case it's not in the range space of AP, then you add it normally to the non-basic to the basic matrix. And what happens if AP is already in the range space of AP? Then, if AP is in the range space of AP, you can compute this quantity. But then, in terms of this quantity, you can, or you are already determined that the dual feasibility region is unbounded, or you can perform a mean ratio test as in the simplex, but you can take advantage of the fact that in case there is a tie, you can perform a multiple deletion. You can get several constraints out of the basis when cardinal of Q is greater than 1. Right? Right. We have seen that it's a generalization of the primal simplex. It's really surprised that it's 25 years after the development of the Gila-Murray dual non-simplex that this was not encountered in the usual bibliography. There are some connection with other authors, and the main connection are with the work of two usual collaborators, because it's in fact a primary feasibility search loop that is used also on quadratic programming problems. In the ocultar is okay. In the proceedings, we have also included some toy samples, numerical toy samples with the A matrix is a 5x8 matrix. The initial basis is only 2 columns from this matrix, and the final one is only 3 columns. You never reach a 5 times 5 basis matrix. Okay, see? And also some sketch of a proof of convergence under a non-degeneracy assumption. Let's proceed to the second part of the talk. And what about the primal, the phase 1? We have then 2 possibilities. The first one is proceeding with it's a primal 2-phase approach, and the second one is the dual 2-phase approach. The dual 2-phase approach the dual 2-phase approach is using as phase 2 the Gila-Murray algorithm. I'm going to focus in this case. Okay. What about the phase 1? Look at the phase 1 is twofold. You are trying to get a dual physical point, a point of the dual physical region, or else you can get a direction of the primal polyhedron because of the Farkas lemma. Really? Really. And in case you do not determine this dual direction of the primal flexible region, then you start the phase 2 with the I, with this dual flexible point starting here. We have three possibilities for the phase 1. The first one is using single artificial variable approach. You can use, given a y hat point, you can compute the slack variables, and then you can transform the problem into one enlarged but one column in which you can obtain a primal feasible point. But in this case, as an example, you can use y hat as the zero vector, and then the initial deficient basis matrix is only one column, the last one. And then this is the corresponding primal to this dual. And then you can show that if there is no dual objective function vector B in the phase 1. You cannot use both information in the two phases. Okay, and in this case you have to solve a sequence of compatible system. You need an anti-cycling rule to prove definiteness of this proposal, and the main point is that you are using the very same algorithmic approach. You are applying to this problem the primal non-simplest artifact algorithm we have just described, but on two different problems. The second possibility is to apply different algorithms to the very same problem. This is the second primal possibility, to apply is entitled dual then primal. What's the meaning here? Here is first apply the dual non-simplex algorithm, and then use the primal non-simplex algorithm. And in the first case, you have to replace in the dual non-simplex artifact algorithm from Gill and Murray, you have to replace the usual mean ratio test by getting the largest of the denominator. This is called in the actual literature the most obtuse angle rule, right? But look at the geometric meaning. AT is the gradient of the linear constraints. This is a direction. This is the angle. In case you normalize this product, you are taking into account the angle of the direction with the geometry, with the gradient of the constraint. You have giving geometrical meaning to all these quantities. It's only changing the usual notation and allowing to shrink the number of columns in A. Right? And there is a third possibility. The third possibility is not solving some compatible system, trying to solve some linear least squares problems. And then you can use the NNLS from Lawson and Hanson, but take into account that the A matrix is a short and fat matrix. Then this problem is not strictly convex. This problem is only convex, right? But you can take the dual, the Wolf dual. In this case, is a problem in which the Hessian is the identity. Then this one is a convex. It's a strictly convex problem, and then you can use all the algorithmic weapons from Wolf and Nani from the 83 in this problem. This is all the possibilities we have been taken into account. From the primal, for the left side of the figure, and there is also the corresponding methodology for phase 2 with Gill and Murray. There is single artificial approach with the dual non-simplex active set. There is also a primal then dual in which you have to replace this mean radio with the greatest denominator. And it's also, I'm afraid to give the K. It's also a non-negative less squares analogous for the dual counterpart. And in this case, note that in case B is in the random space of A transpose, you can directly solve this one and get a primal physical point for this problem. But in this case, the primal and the dual objective function, when you have a dual point satisfying A y equals C, it's constant along all the process. The second part of the talk, and the third part is the main concern. My main concern here. It's working for large scale problems. Then we have to develop some technology with a sparse factorization. When we have to solve in several cases we have to solve compatible system, and in some cases we have to solve less square problem. Then we have two sparse orthogonal approach depending on which one of the algorithmic possibilities we are taking into account. Note that in both sparse solution, you want to take advantage that you have the factorization of AK to get the factorization of AK plus 1 by adding or deleting one or several columns to the current AK. And the first possibility is one of the possibilities is to work inside the static Koleski factor of AA transpose, which is a symmetric positive matrix, or in the static skeleton of A transpose A, which is only positive semi-definite. This is the different sparse solution we gave several years ago. In the first one, it's an adaptation of George and Heath 80s to this structure for the methodology of Professor Sanders in 74. And the second one, the most promising one, is that one in which we try to adapt the Oke-Bjork methodology for using correct semi-normal equations for to be able to work with the Koleski factor of AK transpose. Note that we are trying to avoid the explicit use of the orthogonal factor. We don't want a explicit Q orthogonal because it's dense, it's not a sparse matrix, right? But we are using all these. We have developed all these algorithms, all this sparse solution in using MATLAB, and then we are restricted. We are restricted for to small problems, but we have taken the official benchmark problem from the netbook. We have selected the smallest one, and this is the characteristics. And we have only selected those which can be directly written in with only with no bounds, only with inequality constraints. And this is the optimal solutions we are getting. And to be fair, we have selected the Tom Lab from Kenneth Holmström from Sweden that is also using MATLAB, and it's developing a primal simplex method. And then you can show that he's using a lot of iterations with regards to two modifications of the two-phase algorithms we are proposing. And the difference in time is not spectacular, but there is some difference in time. He was using nearly 1 hour, and we are using nearly 50 minutes. Okay, and that's it. We have developed a different proposal framework than the usual notation. We have proposed a solution, the two-phase solution for both the primal and the dual counterparts, and we have performed some experiments in spite of you being able to help us to solve very large and sparse linear programming problems. Some questions?
Only one question. Regarding your last approach for sparse matrix, it's a comment more from your part. What do you think the need of implementing QR and composition and others when we are assisting a huge increase of memory availability and space? And so how do you manage?
We want to, there is no, the usual primal simplex in dual simplex implementation are dynamic. They are not using a static structure, but we are working inside the static structure because of using the QR factorization, at least the Polesky part. And then I think it's going to be an advantage when some parallelizing procedure can be incorporated in here. And there's a lot of problems trying to parallelize simplex. Yeah. Because, I think because of that.
Yeah. Okay. Thank you again. We will be back in 20 minutes.
We are late.
We are late. Yeah, but we will be back in 20 minutes for the last session of the day.
No, the last session started for 20 past 4.
Go ahead.
So we should now or ever?
We should start or?
I'm not responsible. I'm still responsible.
Just
Fully.
Go ahead.
Coffee and back.
Maybe now because we have some.
Pablo, I think you are.
We are.
A fast coffee and back.
Okay,
Fast as fast as 10 minutes.
Yes.
It's
How fast 4?
okay.
fue lo pero ya está ya una sesión. Pero no era
No, ahora queda lo.
¿vale? No, ahora queda lo que todo organizado de la prensa y
Felipe, Pablo, ¿cuál es el rollo este? Se pone break,
Hostia.
tiene el móvil ahí, ¿yo cómo lo he dejado?
Creo que sí. Sí.
No sé qué.
Me he pasado mucho, me he corrido demasiado. Sí, me he corrido.
Tengo una foto aquí tomando. Esta. PHP Xabreak.
¿La tienes?
Sí, gracias. Nice. Well, very nice.
Coffee.
Yeah, I'm going,
Or
but
you
I.
have,
No,
another session?
Yeah, but.
It's you again?
Yes.
Come on, man.
I'm pluriempleado. How is pluriempleado in
This
Portuguese?
afternoon for me, it's okay. I'm free.
Yes.
Because I don't know if because of my presentation or not, but for example, tomorrow I have the three sessions.
Ah, I see. Where is the
Fred, unmute your micro, please, just to hear you. Fred, can you hear me? Fred, can you hear me? But you can hear me, Fred? Open your micro, just to test. Try now to share. Can you share now? Fred, can you try to share?
I went to the toilet at the end, so I am back.
But
That was it. Start sharing and stop it.
yeah, I already started,
Okay.
for example. Fred, can you hear me? Try to share now. Open your micro.
Is the volume?
Yeah.
Try to type it.
Like I just write.
Who is this presenter? The first one? or-
Fred,
Yes, the first one. If it's Cabral, I suppose. Strange. Well, we will see when the chair
The
arrives.
professor, yeah. So, Nicholas, I will take a coffee.
Okay,
After that, I pass here. to
great.
see You are okay? Okay.
Have fun. Can you hear us? Fred, can you hear us? Fred, can you hear us? Mm,
Thank you, Nicholas.
the first presenter is trying to get things working, but it's not ready yet.
What are you doing? I have my presentation on my, I present in the last one.
I'd
You are using your
rather to
computer?
have the PDF.
But the PDF in pen drive?
I have a pen drive, but if you have one,
Okay. So we are a little bit late, sorry. Wait.
Fred, can you hear us?
So let's start.
We are trying to get Fred to share his screen.
Okay, let's start the third session of computational applications and computational optimization and applications. Sorry, we are a little bit late, but it's interesting discussion toward the last session, and now we will have again, I suppose, I hope. So the first speaker is Frederic Cabral. Is ready?
But we cannot hear him nor see his screen. Can you hear us, Fred?
Where is Frederic?
We are talking through a chat here.
No, we are not hearing you. What is my Claudia? Elysius, can you speak? Can you say something, Elysius, please?
Eligius is not
Elysius
here.
not here. Okay.
It's impossible.
Okay, okay, this working. Just maybe we can start with another. Yeah, I think we don't have the second speaker
It's missing.
is missing. Good, like that we can.
We cannot find the newcomer.
Yes.
Now we can find. You already know that.
I wasn't aware of.
You can
the
share
time.
with us that information.
Here time starts at 6.
Maybe it's high.
Local.
Frederic, you have to put on your microphone.
Okay, so
It's off, okay?
yes, he cannot speak nor share his screen. So we are in hard travels.
You can say that, yeah, that we have the microphone mute and the speaker.
Federico?
Well, I can try to make him the owner of.
No, ask to mute, one mute, yeah.
So I could try this as last resort, but
Federico? Put your microphone on, please. To check. Nicholas, you can start.
am I the next one?
No, the second one is Jacob.
Is Jacob here? He left. Maybe he's trying to reconnect.
one is missing, we are on time. I think.
Federico, can you hear us? Frederic, can you hear us? No. No, we cannot see your slides. You have more than a screen? How many screens do you have? Shall I warn Elias and we skip him, or as you want?
Can you say something, please?
Please type if you can hear us or not, apart from the chat, please. Can you hear us? Ah.
Okay, can hear us?
Could you please, if we enter the YouTube session, it's supposed to. I can hear the YouTube session, so I don't know. It seems a technical problem on his side. And so, shall I tell him to wait? I warn the other, the technical support, and we skip him, maybe?
Maybe we can skip him and try the in-presence presentation, and in the end, we try to hear this presentation. Tell him that in the end about can try to. You can try another browser and try to share.
Yeah, he
and try to
tried.
say keep trying, and then we about 1 hour. Can he, what?
He tried both Firefox and Chrome. No. So,
Google and Google.
and well, Chrome, both. Yeah, I asked that he was at Chrome and now at Firefox.
Firefox has not worked.
Say Firefox is not working. Try.
If you, do you have a link? Okay, if you want, I have your email as the chair.
But do you okay? Can send me the email. He can send. He knows my email because he sent yesterday. Or you put a Rocha,
Juana,
Ana Rocha, just a Rocha.
like this.
Yes, and now the email a Rocha,
Rocha,
arroba ps
DPS,
ponto minho
Minho,
minho new point 50. Okay.
like this.
Yes. Okay.
So next one.
We are going. The second speaker is not here, I suppose. So let's go to the third speaker. That is Nicholas Cruz. So he's on the design of a new stochastic heuristic for derivative tree optimization. So
Yes, so I'm the next
yours, you
speaker.
can
Yes,
start.
of course. Give me a minute, please. Thank you very much for introduction. Thank you all for coming. These are the contents of my talk. We are going to start with a simple introduction. Then we are moving to the method itself. It's a new stochastic method. Finally, we will see some ongoing results and experimentation. Finally, we are going to have see the conclusions and future work. So, starting with the introduction, as you all know, optimization problems are everywhere. You can think of minimizing costs, time, consumption, or the alternative way you can want to maximize performance, incomes, a lot of concepts which are usually difficult to model. We find these sort of problems everywhere in architecture, engineering, and applied sciences in general. Here we see a very nice kind of power facility called solar power tower, which is designed for producing electricity by concentrating the solar radiation on a single point through the use of heliostats. This is a nice example of a place where you can find a lot of different problems. You can try to find the optimal way to distribute the heliostats around the tower. You can find the optimal aiming points for each mirror, so you can find very different functions, concepts to model ideas to optimize. Optimization in practical terms consists in finding the extreme points of an objective function. This function models an idea or something you want to work with. For here we see a plot with an imaginary function. These are the global maximum, the highest peaks, and here we see the global minimum. If we were working with costs, the idea would be to find the global minimum to minimize the function. Otherwise, if we were working with incomes, we would like to find the global maximum. So depending on the function, you will have some constraints which are a direct consequence of the problem you are working with. The type of variables, they can be continuous or discrete. They can be bounded or not. So there are very different types of problems. For instance, when the objective function is linear and the variables are continuous, the problems are generally very easy to solve. However, not every function can be analytically expressed in a full form. For instance, the solar power tower plants depends on complex, partially abstract simulations. So there's no real objective function to deal with, and not an explicit one. because we use simulators, and they are usually computationally demanding too. So we will work with this kind of problem. We have an abstract function called f. We don't know its form. We can only evaluate it, ask for values, and we are trying to consider it too like a time-demanding process. We will also have a set of variables with lower and upper bounds. F will be the objective function, a function defining a continuous space n with n dimensions, and a single result, a projection to a single point in R. These are the decision variables here, and we will be able to evaluate the function as much as we want. However, it's not advisable because the function will be assumed to be slow or computationally demanding. So this kind of problem is generally known as a black box constraint. This is the box optimization problem. In general, we can apply to these kind of problems very rich family of methods called population-based metaheuristics, such as genetic algorithms, differential evolution, mimetic methods such as WIGO or YOGO. Or also in this family, the other main subgroup, we have swarm intelligence methods such as ant-colony optimization, TLBO or teaching learning. And also we have direct. Direct, if you don't know it, it's in contrast to the previous rule, it's the deterministic method, which tries to work with hyperrectangles in the search space to find the most promising regions and to finally find the best result. So this one starts by dividing the search space into hyperrectangles and working with this. It's not stochastic, but deterministic. The problem of metaheuristics such as genetic algorithms or differential evolution is that they have a wide set of parameters to tune, which results in an indirect problem. Besides, they will generally need many function evaluations to convert. On the other side, direct is mainly parameterless, but its exploration method is quite rigid. It starts by splitting hyperrectangles from the central point of the search space, and it has some degenerate cases in which it takes too many function evaluations to find the ultimate more attractive area depending on the structure of the function. So we have worked in a kind of mixture of both ideas called Tangram, whose name is inspired on the traditional Chinese game. It aims to offer a virtual lack of parameters, so to be simple to use, to rely on randomness, to allow working, let's say, in any kind of problem and finding competitive points, to have always the possibility of finding a competitive points with few effort. Finally, it's also have some regular rules to divide the search space, which are somehow inspired by how direct does this. Going in more detail about Tangram, it starts like direct by normalizing the objective function as a unitary hypercube. So we normalize the variables to work with a cube. And the best result now will serve as the guiding point to divide the search space. Finally, the different regions will be addressed or optimized locally with a method known as SAS, which gives this algorithm the stochastic component. This method, Tangram, is intended for low-dimensional problems, less than 20 variables, and low computational budgets. So, for example, when you want to tune a model of a hard or complex simulation. This method only expects as input the number of allowed function evaluations. So you don't need to tune anything, or you are not expected to tune anything. The first step of this optimizer is to evaluate the center of the search space as directed. So this would be the first point evaluated to have an initial approximation of how the function is. Then it compares the budget of function evaluations you have and the number of the dimensions to decide which mode to run. It has two modes, the incisive mode and the standard one. We will see first the standard one. The standard mode has 4 stages. The first one, well, here is a loop. So you start with the first point, the center of the search space. Then you launch the local optimizer, but with a maximum radius covering the whole search space, like in the mimetic algorithm. So during this global phase, this point can be moved anywhere of the search space. This is why it's called global phase. Then it divides, it traces a line from the current result obtained here to each corner and find the midpoint of every one of these lines. And then it launches the local optimizer restricted to these areas. So the same local optimizer SAS changes the maximum step size from the whole search space to each different region. As you can see, there are some overlaps which are positive to compensate the fact that SAS is stochastic. So you will be able to overexplore some regions to ensure finding some attractive point. Also, as the center moves, the window or region is also moved. It's important to highlight, to compare with the other mode, that when you are generating these points, these middle points, after you finish this division, this midpoint generation, you start working with the most attractive points. In case you run out of evaluations, you have already explored the most attractive areas first. And finally, when you finish the local phase of each point, or at least some of them, you select the best one of them as the new current solution. And the process would start again. This one will be a new point for the new global stage, and so on. The local optimizer is, I won't go into much details because it's a simple method and widely known. It's a stochastic hill climber with adaptive step size called SAS. It mainly receives as input a starting point, which would be any of them, this purple one, or these midpoints, and then starts to generate perturbations to move in the search space. The step size is constrained either like this or to the global area, so you cannot move too far from the beginning or not farther than you allow. And this step size is adapted by the times you find better points or not. So the step size of movements of adding and subtracting disturbances is adapted. So I am proceeding this way. The method will not, it cannot return a solution that is worse than the initial point. You will find either the same starting point, so you didn't move, or a better one. If we analyze this, what I've said so far, the first function evaluation is always reserved for the center of the search space. So we would have used 1. Then every loop takes 32 evaluations for the global phase because SAS, we have experimentally tested that the method would not need more than 32 to explore a region. So we would need 32 evaluations for the global phase, and to rise to n considering the number of corners, remember that we need to trace a line through towards every corner. So for the division, and finally, there are additional 32 evaluations for each instance of SAS. So if we have no that much evaluations, it is possible that you will have only rank SAS with the central point and none of this, because if you have too many corners, you consume your SAS budget with the center and the midpoints, but not trying to improve them. In this context, the only really sharp point or explored point would be one, the center, which is a very bad situation because the points are not really competing without being sharp or polished. So if your budget is lower than this, Tangram enters the incisive mode. In the incisive mode, we combine this. In the standard mode, we generate every midpoint and start with the most attractive ones. In the incisive mode, every new point generated is directly launched with SAS to ensure some of the local points to be polished in order to be competitive, at least some of them with the center. Then, if we talk about the experimentation and results, we have implemented these methods in MATLAB and running a MacBook Pro, which is not relevant because the runtime is negligible. Well, as we aim this method to be effective for low dimensionality problems, we have selected from the literature, from this work, as a test bed with 20 box constrained problems between 1 and 10 variables. And we have compared Tangram with these methods. A pure random search, which is expected to be the bare metal reference or the worst method. A plain multi-star configuration of SAS, which is the most descriptive because we are using SAS. If SAS with a multi-star random multi-star configuration works with the same performance that Tangram doesn't improve SAS. So it's a very descriptive test, the use of multi-star configuration compared to our proposal of dividing through the center to the corners. And finally, TLBO, teaching line-based optimization, which is a widespread, very popular population-based optimizer. The limit of function evaluation is computed like this, where n is the number of variables, which is the same strategy proposed in the source of the set of test beds. And we have launched each problem 200 independent runs. Why? Because every time you run the optimizer, the results vary because of the stochasticity. So here we can see the results. These are the problems, names, dimensions, the best point. The budget is very low. This is a very low budget if you are not using any information. So it's normal, it's expected as the authors of this work say that results are not really global or finally. We are assuming a context in which a single evaluation could take days. So we are trying to get the best point we can with a few resources. And the problem, each method, and in bold font, we see the best result on average with the standard deviation. As we can see, Tangram wins always to the four main methods, PRS, MSAS, and TLBO in all the cases. Here it has been run in the standard mode because the budget allows it to use it. Here, the incisive mode is selected, but it makes this optimizer to win too. We make an internal experiment of launching Tangram with them in the standard mode too by bypassing the selection. And without the incisive mode, it failed. It is outperformed by, I think that by TLBO and MSAS. So the incisive mode effectively makes it adapt to the worst scenarios for the kind of method. So then the Tangram won 20 of 20 cases, and we were very happy, but we also take inspiration from Direct. Then we looked for a recent Direct implementation on version GL and compare our method against it. In this case, Direct GL won 12 of the times and Tangram only 8. So Direct performed better. To compensate this situation, we decided to try a real model tuning problem, a hard one. This model tuning problem, which we are working with at the University of Granada, a single function evaluation takes almost 2 hours. It's a problem in which you try to train a realistic neural network, not an artificial one, but a realistic one. So you can see it as a mini brain to learn a pattern. So with this real model tuning problem, which takes an expert months of work to find the more realistic one, we launched it both, and Tangram was superior to DirectGL. And the aspect that it is stochastic allows you to rely on the lag key of using several independent runs. With Direct, you go as far as you go. If we obviate the epsilon parameter, which usually has few effects, so with Direct, the mobility is less. With Tangram, which works better in average and is also faster, you can also trust or rely on your luck and launch several independent runs, which is the positive effect of each stochasticity when you want the better point as a point as good as you can. So we compensated the partial failure of the synthetic test bed with a realistic problem, which our method works better than Direct. As a conclusion, some feature work, we have described a new derivative-free black box optimizer called Tangram. It's visually parameter-free and aims to be effective for model tuning, less than 20 variables. It works in a unitary hypercube and follows a deterministic strategy in which it tries to move from the center to the corners. But it's also able to adapt its behavior by considering the problem dimensionality and deciding between two modes, the standard one and the incisive one. It relies on a local optimizer called SAS to work at 2 levels, the global one covering the whole search space and the different regions, which are also in movement. We have addressed 20 benchmark problems with few function evaluations intentionally to simulate a very hard context, and Tangram performs better than the initial group of methods. It lost if compared to DirectGL, but we won the real application problem. So as you may all know, there is no freelance. There is no search algorithm that is perfect for every problem, especially when we work with black box functions. But Tangram seems to have good potential for certain applications. As feature well, we will try to detect the convergence of SAS to save more function evaluations. I mean, to being able to self-adapt the 32 golden value more to save some of them and increase the benchmark problems. Finally, we will also try to rethink some parts of the method to make it more competitive. And that's all from me. So thank you very much for your attention.
Any question?
First of all, congratulations. Very, very nice work. I don't know if I have many time for questions. I have a lot of questions. The first question is, it's the first time you present this Tangram?
It's the first time I presented because we sent a preliminary work. We didn't include the incisive mode. So this is the most sophisticated and current Tangram method.
very, very nice work with a lot of potential. The second question is, you were very honest, which is very good because you compared yourself with Direct. And it was very smart to use a real world problem because in that problems it's where you really test your software, because sometimes in benchmark problems it's not as real as real world problems. And the search question is there is a lot of direct search methods.
Yes.
And direct is one, but direct lose to other direct search methods. For instance, many other. For instance, there's a group in Canada that has a very nice direct search, and there is a group in Coimbra that has very nice direct search. And for instance, pattern search. Did you compare with that? Did you plan to compare with them? Because they are very competitive.
We plan to compare with them, but we select this one. I think it's very interesting for you all. Here we go, optimizer. It's a framework with direct method.
Commissions?
Pardon?
Commissions? All of these commissions?
Yes.
That one? Yes, what's in?
We choose, instead of choosing plain direct, which is 25 years old, we look for a reason, very recent. In fact, it's a preprint of our partners from Lithuania. They have framework, and we chose direct GL, which in theory was the best option in the recent study. The GL improves the selection of rectangles. So, but in any case, we appreciate your suggestion, and we look for more. You said from Canada and from?
I'm from Coimbra.
Coimbra. Okay, thank you very much for your comments.
Okay, thank you. Any more questions? Just a curiosity that I was not paying attention maybe in the beginning. Well, why did you call the method tangram?
Yes, because if you work in 2 dimensions, you look at these kind of pictures, a point with triangles inside, it looks like the traditional Chinese puzzle, but it's not farther from that. It's just marketing. So,
Yeah, but the name is very nice.
Thank you very much.
So any more questions? So let's thank you again. I have here
Stop sharing.
The presentation of the first speaker. I don't know if I can share or what can I do with it.
The presenter, the program is here.
I don't know if I can share.
Who is trying to share? The first. Cabral.
It's Beatrice, no? The presenter, isn't it?
Frederick Cabral.
He sent me the. Maybe you can open.
Open.
Do you have email over there to open the?
Yes.
That he sent me.
Yes.
What is your email?
N. Calvo Cruz, I'll type it.
Send me in the chat. Please.
Okay.
Let me see.
So you have already sent it to me? Or?
I'm not seeing your message. What is your email?
It's in the
I'm not seeing.
in the Jitsi.
I don't have no, I'm not.
ncalvocruz@wal.es.
And now, and Cal,
Calvo Cruz,
Calvo Cruz,
wal.es.
Wow.
UAL dot S. Yes. UAL. En Calvo Cruz. Okay.
It's the pressure.
I'm not, I don't send it, I don't know why.
You cannot send it.
I do not have that.
Okay. Try to NCCN.
So they are here. Go. Maybe
You can enter your email there.
so maybe you can write.
Please in the Jitsi chat, please. This one. It's I tried. I wanted to stop sharing, but could you give me the access? Or
I have to remove one.
Because can he speak? What's the point of showing the?
Maybe we can go to the last.
okay.
He cannot speak, so what's the point of showing the?
Not showing, it's a video.
Yeah, it's a
Of the
video.
presentation.
That's why we want. If you download the video, you can copy it to my USB key.
When I try to open the video, okay. But when I do like this,
It doesn't work like that.
I don't know if it's something wrong on my computer or not.
Maybe it's do you have internet? I suppose.
That's so good now.
We
Okay, let's
can,
move
yeah.
to the last speaker and see if we can see the first episode. Last speaker is Beatriz.
Thank you.
She will solve.
There is space for this one? There is space? Or no?
Yes.
What's the name of your presentation, Beatriz? I lost it.
It's a presentation.
PDF or this one?
Yeah.
Okay. I'll start sharing.
Okay. Beatriz will talk about analyzing mapping platform through clustering.
Here you have it.
Hello, good afternoon. I'm Beatriz Flamia. I'm a PhD student at the University of Minho and also at Polytechnic Institute of Bragança, both in Portugal. I will present the work analysis in the MIT platform to clustering algorithms. This paper is cited by me, Beatriz, and also by Yaya Moura, Ana Rocha, Florbela Fernandes, Fátima Pacheco, and Ana Pereira. My presentation is divided in 6 main points. First, I introduce the paper. Thereafter, I briefly present the MIT project, followed by the motivations and the main objective of this work, the methodology, that is the use of clustering algorithms to analyze the MIT database, the results achieved with this methodology, and the main conclusions. The age of digitalization forces education systems, students, professors, universities to adapt in order to create a more dynamic and interactive environment than traditional classes. Traditional classes are often considered boring, monotonous, and sometimes ending up to dismotivate both students and professors. In this context, universities have been encouraged to adopt innovative methodologies and teaching tools to become the learning process more pleasant, both for students and for professors. And besides, COVID-19 pandemic show us how much investment is still necessary in technological research and literacy to strengthen the current educational system. Particularly, mathematics, as we know, is a pillar of several higher educational courses. And this subject is the one of disorientation and complaints for students at all levels of their education. So one way to change the student pragmatic view in relation to mathematics is through iterative learning platform. In this context, the MIT platform was created. MIT is an e-learning platform focused on mathematical contents of higher education. This platform is being developed by 7 institutions from 5 European countries, Portugal, Ireland, Romania, Italy, and Lithuania. Currently, there are 1,208 students enrolling. These students belong to 13 nationalities, and we also have 99 professors from 11 countries. On the platform, any students or professors can do the registration, and these users can have free access to videos, exercise, training tests, and pedagogical materials about mathematics contents of higher education. Currently, on the platform, we have 1,605 questions divided in 15 topics and 18 subtopics, as presented here in the figure. The top and each subtopics inside the box. All the contents available on the platform are divided in 2 difficult levels, basic and advanced. But previous investigators found out that this division is not enough, it's not the best way to organize the platform. So this work aims to investigate more deeply this aspect in order to improve the platform and also to provide for students a best way, a best platform to study, to train mathematical contents. The MIT platform is mainly divided in 3 sections: students assessment, MIT library, and community of practice. These works will only focus on the students assessment. In this area, the students assessment, the students can have opportunity to self-evaluate their knowledge on mathematics. In this area, in this space, we have 2 areas. a training area and a testing area. And the first one, the student need assessment, is the area for the student training a content of mathematics. So the students are invited to answer a set of questions, and after the confident, he can perform a test to evaluate the behavior, their skill. But these works will only focus on the data of training, on the training area. On Matthew, we also have the library where the students can have a collection of videos, teacher materials about the topics and subtopics covered on the platform. And we also have our network, that is the community of place. We have a community for students community, and the lecturers community. In both of them, the users are invited to share teaching and learning experience. As already know, the METI project, the motivations of these works consist in of improve the METI platform, making it more iterative, able to make decisions, offering to professors and students a customized platform of mathematical learning. That is what we want in a near future. So these works aim to investigate an optimal number of difficult level to reorganize the questions available in the METI. For this task, the information of the questions answers at the students' need assessment, that is the training area, over the 3 years that the platform is online, were considered and analyzed by clustering algorithms. Basically, what we want here is ranking the question that was answered. The question that was answered more time correctly will be considered easier than the other ones that was answers more incorrectly. So we choose clustering to analyze the database. Clustering consists in the text to grouping the data set, the elements that belong to the data set, according to similarities and dissimilarities, analyzing the characteristics of each element. In this case, we opted to use hierarchical clustering and also partitioning clustering. In terms of the hierarchical, we have all the data on the root node, and these data are being divided in, according to the branches, by the algorithms that will be constructed a binary tree. So at the end, we have a clustering division, and we have the groups. And on the partitioning, the algorithms will decompose the data set into a disjoint cluster. So in this case, normally the algorithms requires the number of clusters, but this task is not an easy to perform. And in our case, that is the main point of our investigations. Decide in how many clusters we need, how many clusters we have, and these clusters means how many difficult level the platform will have. To do this, we opted to use an automatic clustering algorithms. For this, we use the David-Bode index that is performed in 4 steps. First, it's necessary to evaluate the distance between the elements until the candidates to be a centroid. Thereafter, on the second steps, we evaluate the distance between each candidate to be a centroid. On the third steps, we have a relationship between the 2 previous steps. And finally, on the 4 steps, we have the David-Bode index that's provided by these equations, where Ri is the maximum value obtained on the third steps that represent the worst in case with two-bit cluster, ratio of cluster I, choose the optimal clustering solution, has the smallest DB index, and clearly we have a minimization problem whose objective function is the DB index value. And to solve this, we are using some bio-inspired optimization algorithms. The results. The data collected over the 3 years that the platform was aligned were considered here. So we have 6,942 answers of 766 questions in the 15 topics available on the METI platform. On the table, we have the descriptions of this data. This data was provided by 285 students of different nationalities, And on the first column, we have the number of questions available on the platform divided by each topic. On the second one, we have the quantity of questions answers. The third and the fourth, we have the type of answers, it is correct or incorrectly. And at the end, we have the total answers collected on the platform. We are evaluating the probability of hit questions. So we know that if you are comparing a question that was answered 20 times, the probability is completely different than a question that was answered only 2 times. For these reasons, we opted to divide the data set in others 3 ones. So the first, the second, the third, and the fourth data set is part of the first one. That was done to achieve great reliability in terms of the results. So the first data set, we have all the questions that was answered at least 1 time. On the second one, we have the questions that was answered at least 5 times, and the third one 10 times, and the fourth, the questions that was answered 15 times at least. And here we have the descriptions of how many questions we have in each data set according to the topics. In terms of results, here we have the results of the hierarchical clustering. In this case, the similarity distance between the clusters become smaller and smaller as the data set becomes more restrictive. It's noted comparing the first graph with the others. Here we have the similarity measures. This is larger than this one, so that's the reason that we have these conclusions. And in this case, we have to choose and how many clusters we want to divide the data set. So it depends on the similarity measure. As I previously mentioned, 2 difficult level is not enough. And the most prominent question here is, what is the best value to have a cut line, because we are working with an hierarchical cluster. 2 is not enough. So if you choose the red line, like this one, or the first that in red, means that we have 3 or 4 clusters. And maybe it's not provide much difference on the platform organization. So we are trying another possibility. Another possibility can be 7 or 8 clustering. That's represented in the green line. But it will imply in groups with few questions and high similarities. And it's not good for the platform, it's not what we want. So we decided to try a middle line between the previous ones that is represented in black. It means 6 clusters. And it's expected with 6 clusters maintains the balance between similarities and dissimilarities of the questions at each level. So in this case, 6 will be the optimum value. But we know that this decision have much of the person, much influence of the people, the authors' opinions. So to compare the results, we also use the partitioning cluster. In this case, that was the David Bolt index I had already mentioned. We need to select some optimization algorithms. In this case, we selected 3, that is GA, PSO, and DE, to indicate the optimal value of the DB index. Here we have the results, the value of the DB index, and the number of clusters that each algorithm with each data set was resulted. As we can see, we have 12 possibilities for database and 3 algorithms, 12 possibilities. And out of the 12, 7 point out that 6 is the optimum value. So these conclusions are similar to the previous one. And here we decide the optimum solutions according to the smallest DB index. In this case, was provided by differential evolution algorithms. It's also 6 numbers of difficult level. And here we have the image of the clustering provided by the optional solution, this one. In this part, in the topic, we have the divisions of each line to represent a topic. And here we have the probabilities of a question to be hit. So the smallest probability means the questions is more difficult than the others because it was answered more times incorrectly. And the question that was answered more times correctly have a higher probability, so it's easier. So the most difficult level is this one, and the most easier level is this one. I forget to say, but considering the data presented previous, linear algebra is the most used topic on the platform. So more than 50% of the questions answers is provided by this topic. For this reason, we analyzed only these topics in order to investigate if the conclusions are the same inside the topic. And out of the 12, 1, 2, 3, 4, 5, 6 point out 6 as the optional solution. So we conclude that 6 is our optional way to divide the platform. So in terms of conclusions, e-learning has already operated a transformation in higher education, and online platforms such as Mati is an opportunity to make learning more accessible. Although Mati is focused on mathematics, their skills developed with e-learnings can be expanded to other professional and personal activities. So in this case, Mati can represent more than a simple e-learning platform. And in terms of the methodology, the algorithms points out that 6 levels of difficulty is our optional solutions for the reorganization of the platform. By this way, a more accurate division of the contents tends to motivate the students, since the students will be able to better follow the advancement and critique of their knowledge when moving to different difficult levels. By this way, in terms of future works, the reorganization of the platform is necessary, and we are trying to keep this work in this line. Here I have my main reference. Thank you very much for your attention. I left my personal contact and the contact of the project coordinator. All students and professors are very welcome on the platform, so thank you again, and I'm available for questions.
Okay, thank you. Thank you very much, Beatriz. Any questions? We are run out of time. Okay.
It's not a question, it's a remark. It was a very nice work and an excellent presentation. And out of curiosity, why do students answer more linear algebra questions than the other subjects?
Probably because linear algebra are more present in the higher educational courses than the other, because it's a basic subject in many courses, not only on the exact courses as engineers, but normally we have linear algebra in administration or other courses that not.
Okay, thank you.
Thank you very much.
That's very interesting, because we are eliminating linear algebra from our career.
But it's common in the other countries.
Really, in the reference, too much more understanding.
Okay, thank you, Beatriz, again. She knows a lot. I don't know if Frederick is able to talk with us now, but the suggestion was to move to reschedule his presentation. Frederick, if you can try to say something to us, if possible. Okay, he's saying to try to open the video. final version.
Hi, good morning, everyone. My name is Frederico Cabral. I'm from Brazil. I'm from the National Laboratory for Scientific Computing. And I'm going to present our paper entitled Reducing Cache Miss Rate Using Thread Oversubscription to Accelerate an MPI OpenMP-based two-dimensional Hotmail method. So let's start talking about the Hotmail method. It's a finite difference scheme designed to solve the convection diffusion equation in a particular way that we don't need to solve any linear system between time steps. So it behaves like a total explicit method. But as we will see, it interchanges implicit and explicit operators, so the method is stable. I'm not getting into too much details about the Hotmail method, but let's just consider the two-dimensional convection diffusion equation here. Pure diffusion equation. And then the four subsequent steps, we interchange the explicit and implicit operators, first for the first same step, and then for the second same step, that in a way that in total we have here one time step. Interchanging these operators is the key to not to need to solve any linear system between time steps, because this scheme allows us to use the only explicit use information that are totally available at the previous time steps. So here we have a simple naive implementation of a version of an OpenMP version where we just put pragma only parallel before each one of the 5 steps, each one of the 5 main loops. But this scheme is not a good one to obtain good speed-up results. So we designed some years ago a scheme named explicit work sharing with adjacent synchronization that works the following way. At the beginning, each MPI process computes its partition mesh. We have an explicit work share scheme, so each MPI process knows it is able to compute a priori in which part of the total domain it's going to work. And then the same thing is done with each OpenMP thread. The OpenMP threads are obviously inside MPI process. We have threads inside process, of course, and each OpenMP threads is able to compute its local mesh inside the partition mesh inside, which is inside the MPI process. And we have a strategy here that eliminates the implicit open barrier by explicit lock mechanism that works the following way. Before in all of the 5 loops shown before, they are present here, but I didn't have some space to write them here, so this loop is representing all that five steps. We set a lock, and only after this loop, we set this step as unlocked. Why does we do that? Because this information is used by each one of the thread neighbors to know if this loop is already computed or not. And then each thread here is going to wait for its neighbors, for its right and the left neighbors. So here, with this unlock, I'm saying to my neighbors, I'm done. I'm done my work, and here I'm checking if my neighbors have finished their work. And with this mechanism, we can speed up a little better than the naive way. But this work represented here, we go a step further in the process. As we can see here, suppose here we have n MPI processes, and this one in red is the nth process. And inside this process, we have 3 OpenMP threads. We can notice that the size of the mesh, which is computed by any of the threads, is inversely proportional to the total amount of threads, to the thread numbers, total number of threads. Because if instead of 3 threads here, we had 6 threads, each one of them would have half of the size of the mesh for them to work. Why is that so important? Because as the number of threads increases and the size of a local mesh decreases, this local mesh tends to fit into the memory hierarchy, especially inside the cache structure. So that's what we're going to show here about using our experiments. We performed some experiments in two different machines, and the first one is composed by a total of 32 physical cores, and the second one is composed by 4 Intel Xeon with 26 physical cores with hyperthreading, with total 2 threads per core. So we have 52 threads per socket with 4 sockets. So we have 208 threads totally in this computational room. Our parameters in the experiment are shown here, where the domain is split into 10 to the 4 by 10 to the 4 points, and we performed 10 to the 3rd time iterations. As I mentioned before, the velocity and the diffusion coefficients are constant, and here we have the same same illustration that I showed before. And here we can see our first interesting result, where we increase the number of total threads, even achieving much more than the total number of physical cores inside the available in the processor. We're talking here about a computational node with 32 physical cores. At this region here, until about 600 to 650 threads, we don't observe any difference. But from this point on, the speedup starts to climb, starts increasing until a point that's near the total number of physical cores. So it starts to be proximal to 100% of efficiently using of the computational resources. But why does it happen? As I mentioned before, as the number of threads is increasing, the total number of the total L1 cache miss count at our optimized version starts to decrease, while at the naive implementation with the 5 loops with the pragma open before, it starts to grow. And it continues growing here. It's still increasing the whole time. And when the number of the total count of cache miss is reduced, what happens here is that it allows more speedup. The same thing happens at the L2 cache miss count. Here is the L1, here is the L2. The naive version presents a count that increases all the time, but in our optimized version, it decreases until reaching some stable point here. And the same thing happens to the last level cache miss count here, which is the L3. We have at the same region a strong decrease of the LLC miss count, and at the optimized version, and at the naive version, it continues increasing. But here we have some interesting happening. The total LLC cache miss count for the naive implementation decreases, but it's not enough to speed up the application because L2 and L1 are still very high. And that's the reason we can observe this speed up increasing here, this machine. We evaluated too the spin time, which is the synchronization time used by OpenMP at the least barriers. And we can notice here that the naive implementation has almost 70% of the spin time used inside the total CPU time. The spin time and by the CPU time ratio shows us that at the naive version, the proportional, the spin time proportional is too high, while at our optimized version, it's not so high at all. It's also a result of the diminishing of the total cache miss counts at all levels. And to be fair at this comparison, we are looking here the overhead time caused by the excess number of threads, and we can observe here that in both naive and optimized version, the blue one and the red one, this ratio is practically the same. So the overhead time caused by the increase in the number of threads affects both versions at the same way. But beyond that, we can observe that they are very, very, very small impact. Here we have only 1.4 maximum, 1.2 maximum, 1.2% maximum of the overhead time proportional to the CPU time. And here we have the total CPU time. This information is important to be fair. This comparison, we must show the total CPU time. And as we can see here, the total CPU time starts to decrease as the number of threads are increasing at our optimized version, and our basic naive implementation, this total CPU time still remains very, very, very high compared to the optimized version. So it's a consequence of the time we are losing caused by a very high count of cache misses. And at the second machine, which has 2,208 threads, we can observe here is a result much better than the previous machine. At this machine, the total speed up gets higher than the total number of physical cores available, which is 104. So here we can maybe we can say that we achieved a super linear speed up, because we have a speed up about 168 with 104 physical cores. So yeah, we can observe here that our strategy that is working very well to reduce the cache miss count, and this reduction of the cache miss count is responsible for this speed up, as we can observe here. At this work, we didn't apply any other techniques to reduce cache miss, as tiling, for example. And one of our future work is to mix many strategies to reduce cache miss here. But here we are trying only this strategy, which is the thread oversubscription, which means that we are using many more threads than the number available at the physical cores, and we are getting a very good speed up here. So our main conclusions are that the first machine, the speed up was increased to 25, which is near the total number of cores, that was 32. And at the M2 machine, we get a higher number than the total number of physical cores. And the reason, as I said before, is the reduction of the cache miss count that happens as the local mesh gets smaller. So that's it, and here I'm available to answer all the questions. Thank you very much for your attention.
Thank you, Frederico. Any question? Oh, I think you cannot answer loudly. Can you hear us? Guess I'm not able to speak.
Okay, I have some suggestion.
Okay, but he will write. Okay.
Writing can.
Yes,
I don't know if you hear in the session by YouTube. You can hear the. Okay.
Yes,
you can write.
that's a good idea, but there's a
Yes,
certain lag. So there's like 10 seconds of delay. So.
Okay, you will hear some suggestions from here. Okay.
First of all, if that better.
Maybe you can come here.
Louder.
First of all, you have to take care about the affinity of threads to core, because perhaps all your threads are in the same socket. So when you enlarge the number of threads, you are using more socket, and then you have using the cache of every socket, so you have more memory. You know that. So this, I don't know if this was taken into account. I think this is quite the reason when you enlarge the number of threads, you have more memory because you're using more cache. I think the best if you have 4 sockets and you have 4 threads, each thread has to be in one socket. Okay.
Okay. Thanks for the suggestion. You don't have to say something, all right? Any suggestion? No?
There is definitely interaction. So.
Here you can see the email in case you want to write him.
Okay. So thanks again. And Federico, see you next time. So this is the end of this session by today. Thank you all. And tomorrow, not tomorrow, the day after tomorrow, we will have another session. But tomorrow we'll have a session of Paula, the talk of Paula Amaral that is in the general practice session. You cannot move in the morning. Okay, thank you. See you. Nicholas, thank you very much. Leo, thank
You're
you
welcome.
very much. I'm just finishing something there and then I'm going to the city center. You are going to the center also?
Now I'm going to afford it. I don't know what's.
Yes, the whole country.
But I want to ask something to Nick.
Which hotel are you? Huh? Which hotel?
Alameda Center.
Alameda. Okay. I think I'm supposed to be here.
¿Tiene tiempo, Nicolás?
Sí. Dime.
Duerme. Sí, pero duerme. Está aquí hasta el segundo la persona. Es que el método se parece mucho a lo que he hecho yo ahora con la cosa. Ahora, ¿por qué coger